Example 1, you're going to have a lot of different examples that look kind of like this. But it says, given cosine theta equals 3/5 and sine theta is less than 0, find sine 2 theta, cosine 2 theta, and tangent 2 theta. So we've got 3 different things to do. Let's do sine 2 theta first. Okay? Sine 2 theta. And don't think that it's just going to be as easy as multiplying 2 times 3/5. That doesn't even make sense because 3/5 is an angle. 3/5 is not a theta. You're not just multiplying 2 times 3/5. Doesn't make sense. Find your identity. Okay? Find the identity that talks about sine 2 theta. Or on the board it says sine 2a. If I'm talking about a double angle for sine, the formula says 2 sine theta cosine theta. Straight from the board. Okay? This looks like a problem that we've done before. We've got 2 holes to fill. Now they gave us one of the holes. They gave us cosine theta was 3/5, so we should be able to fill that in. But what we're missing is that sine theta. Okay? We're missing that sine theta, and some of you know because you've seen this problem before. It is very familiar. We want to know what sine theta is. And so what you're going to do is take this given information and either draw a picture, like we've done before, or use one of the fundamental identities, like we've done before. I think most of us would rather draw a picture. When we see cosine is a positive fraction, and this says sine is negative, they're telling you which quadrant it is. Okay? Cosine is positive, sine is negative. This must be telling us quadrant 4. Right? Because the x numbers are positive over here, but the sine numbers are negative down here. Okay? They're talking about quadrant 4. So what I'm going to do is I'm going to picture an angle that puts us in quadrant 4, but I'm going to make a triangle out of that. Okay? That triangle has reference angle theta. That's my triangle. Okay? So they gave me the cosine ratio. The cosine ratio is x over r, so that's 3/5, 3 over 5 right there. I'm going to do Pythagorean, and we've seen this enough times. You've seen Pythagorean enough to know that that's going to be a 4. Okay? But in the 4th quadrant, that's a negative 4. The y numbers are negative down there, so that's a negative 4 from the ratio. And what that tells me is the sine ratio, sine theta, is going to be y over r, negative 4/5. Negative 4/5 sine theta. And so once you've got all your holes filled in, just multiply. You're going to multiply. Negative 4 times 3 is negative 12 times 2 is negative 24. And 5 times 5 is 25. So next, let's do cosine 2 theta. Cosine 2 theta. Cosine 2 theta. We've got 3 different choices there. And so really you want to pick one. It doesn't really matter. I would probably use the one that has just cosine in it because that's what was given to me in the problem. Okay, so I would probably choose the identity that says 2 cosine squared theta minus 1. Just because, for a couple of reasons. One, I only have one blank to fill in. But they gave me what that value was. They gave me cosine theta was 3/5. So really, I'm just filling in that hole, and I'm going to square it and multiply times 2 and subtract 1. So let's clean that up. I see 2 times 9/25, once I square that, minus 1. Or 18/25 minus 25/25. Cleaning up my fraction. That's a negative 7/25. Cosine 2 theta equals negative 7/25. So then lastly, let's do tangent 2 theta. And so you're going to start with the formula. Look at that identity. That identity says 2 tangent theta over 1 minus tangent squared. And so we've got a couple of holes to fill in. And I don't know what tangent theta is. Okay? When I can figure it out, go back and look at the picture that we already drew. Okay? You can use identities, but I'd rather look at the picture. If I look at this picture, remember tangent theta's ratio is y over x. So can anybody tell me what tangent theta is from this picture? Negative 4/3, right, y over x, negative 4/3. And so that's what I'm going to fill in to these spaces. That's tangent theta is negative 4/3. So we fill that in. And then we have to do some algebra with to clean up our fractions. So we've got negative 8/3 on the top, and on the bottom I have 1 minus 16/9. Let's just square that. And so common denominator, let's call that 9/9. So we can add our fractions. You're constantly having problems where you have to add fractions and get a common denominator. Okay, we do that over and over again. I see negative 8/3 all over. 9 minus 16 is negative 7. We've got negative 7/9. We're dividing fractions, so let's multiply by the reciprocal. I would see negative 8/3 times negative 9/7. 3 goes into 9 3 times. We've got negative 8 times negative 3 is 24. I've got 24 over 7. Tangent 2 theta equals 24 over 7. Yes. Okay, so this is a very common problem. You're going to have to do that, but in order to do one of these, just find the right identity on the board or on the formula sheet. Example 2, we're finding the values of the 6 trig functions. I think that makes it a little bit difficult because we've got a lot of stuff to do. On your homework, I think it's just going to ask you to find, maybe just ask you to find sine theta, or maybe just ask you to find cosine theta or something. Maybe just ask you to find 1. But when we have to find all 6, then remember what we have to do. We've done this, we haven't done this in a while, but we did this a lot in chapter 5 and maybe in chapter 6. But we had to find all 6 of those trig function values of theta. So look at what you have given. Cosine 2 theta equals 4/5, and 90 is less than theta is less than 1/8. So think about what that means. Between 90 and 180 is talking about the second quadrant. Okay? 90 degrees and 180 degrees, they're talking about quadrant 2. And so I feel like they're describing the picture, but whatever. Look at what you have given. Cosine 2 theta equals 4/5. So what you probably want to do to start with is start with your identity for cosine 2 theta. Cosine 2 theta. You've got 3 options for the double angle cosine, and so we can start with any of the 3. But I would probably recommend you start with one of them that only has one identity on the other side, one function on the other side. So if I want to find sine theta first, let's use the cosine 2 theta identity that just has a sine theta. 1 minus sine. Wait, I always forget that too. 1 minus 2 sine squared theta. Okay. We're going to fill in the blanks as best we can. We're going to solve for sine theta. I know cosine 2 theta equals 4/5, so we should be able to fill that in right there. 4/5 equals 1 minus 2 sine squared theta. I'm trying to write small because we've got a lot of stuff to write. If I'm going to solve this, I'm going to isolate the sine theta, basically. And so isolate just like any other algebra equation, we're going to subtract 1. And that's 5/5. So if I subtract 5/5 there, it's going to be 4/5 minus 5/5 is negative 1. Negative 1/5 equals negative 2 sine squared theta. If I'm trying to isolate sine theta, I'm going to divide by this negative 2. Now here's the little trick. Okay? I've already got a fraction bar there. I've already got a division sign there. So when we divide by negative 2, it's just going to go underneath the fraction, or on the bottom with 5. I'm dividing by negative 2 and I'm dividing by 5. Okay? So that's like negative 10. I would have negative 1 over negative 10, or positive 1/10 equals sine squared theta. So almost there. I just have to take the square root of both sides. Okay, if I want sine theta, I'm going to square root both sides. Actually, it's plus or minus square root. But remember, we're in the second quadrant. So what do we know about sine in the second quadrant? Sine in the second quadrant is positive. So we're just looking at that positive root. Square root of 1 is 1, so we have 1 over the square root of 10. That's sine theta. Or, once you rationalize, sine theta equals square root of 10 over 10. That's part of our answer. This question asks me to find all 6 trig function values. Maybe on your homework, though, we'd be finished. maybe it only asks you for sine theta on your homework and you'd be finished. Now, once you've got one of them here, and we need to find the next one, probably going to find cosine. You've got some options. You could go back to your cosine double angle, or you could go to your Pythagorean identity, sine squared plus cosine squared equals 1. That might be a good way to go. You've got several different options. Just pick one and go with it. I think maybe we'll go with that. Sine squared theta plus cosine squared theta equals 1. Okay? So, go back to right here where we had sine squared theta. It's 1/10. Or I suppose you could take your sine theta and square it if you want, but you're going to get 1/10 there. Plus cosine squared theta equals 1. I'm going to solve for cosine theta. So let's subtract the 1/10. And cosine squared theta equals 9/10. And you can take the square root of both sides, plus or minus, right? But again, remember, when we do this, we have to remember that we're in quadrant 2. And what do we know about cosine in the second quadrant? That one's going to be negative. So we're looking at the negative square root of 9/10. Cosine theta is going to be negative square root of 3, or negative square root of 9 is 3, over square root of 10. Or rationalizing that, cosine theta equals negative 3 square root of 10 over 10. So now we've got cosine theta. Tangent theta, again, I've got options, but I think the easiest way to find tangent theta is do a sine over cosine. So if I was going to do tangent theta, I might do sine theta over cosine theta. And so we're going to divide our sine theta value over our cosine theta value. Now, here's a hint. The unrationalized version has the smallest numbers, and it's going to be easiest to work with. So I'd probably go back to my unrationalized value for sine, 1 over square root of 10. And my unrationalized value for cosine was negative 3 over square root of 10. I think it's easy to see what's going to happen. Square root of 10s are going to cancel. If you multiply by the reciprocal, square root of 10 over negative 3, you're going to see those square root of 10s cancel out. You get negative 1. So tangent theta equals negative 1/3. There are your big three. So find the other three, the reciprocal functions, just by flipping. So I know cosecant is the reciprocal of sine. We're going to use the reciprocal. Again, go back to your non-rationalized version when you're going to do the reciprocal. That's going to be the square root of 10 over 1. Square root of 10. When we do secant, secant theta is the reciprocal of cosine theta. And again, go to your unrationalized. When you flip, we've got square root of 10 over negative 3. Negative square root of 10 over 3. I don't like that negative on the bottom. We'll put it on the top. Negative square root of 10 over 3. And for tangent, for cotangent, reciprocal is negative 3. That's all 6. Now again, I did all 6. That's a lot more work than I think you're going to have to do on your homework. On your homework, they'll just pick one. But it's the same process. Find an identity, and then basically isolate your example 3, verify this identity. Okay, verify this is an identity. So we got cotangent x sine 2x equals 1 plus cosine 2x. Okay. So what your job is on these verify, every single one of them, okay, every time is to try and find some identity hidden inside it. Okay? So, in general, we want to take an identity and use that identity and then do some kind of algebra and stuff cancels out. Use an identity, use some algebra, stuff cancels out. That's pretty much what it is. Remember, our goal is to show the left side equals the right side. Okay? So, let's work over here on the left first. See this? Sine 2x? That should kind of jump off the page at you. That's one of our identities. All right? Sine 2x, look at the board, is going to be 2 sine x cosine x. Okay? Now, what we can also do at the same time, a trick that we use that comes up often is change everything into sine and cosine. So cotangent x is cosine x over sine x. And so we've used a couple of identities, and now maybe something will happen algebraically. Okay, we got to see what's going to happen. Sine x is going to cancel itself out there, and so if that cancels out, let's clean this up. What I would have left is 2 cosine squared x. 2 cosine squared x. And so I'm kind of stuck there. I don't really know what to do. It doesn't look exactly like the right side, but let's say we're stuck. Let's go over and work on the other side. Because on the other side, I see another identity. Okay? I see 1 plus cosine 2x, but cosine 2x I can do something with. And so you look at cosine 2x, and you've got 3 choices here. Cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. Any of those 3 would be valid, but compare back over to this other side. We don't want to use either of the choices that have a sine in it. We're trying to get rid of any kind of sine, or we only want a cosine in it, basically. So the only choice that I think is valid for this identity is to use that third choice where it says 2 cosine squared x minus 1. Okay? I'm just going to bring down this 1. We have 1 plus 2 cosine squared x minus 1. I just use that identity on the other side. But notice what happens here. The 1's are going to knock themselves out. 1 minus 1 is 0. And so we are just left with that 2 cosine squared x. And that's exactly what we wanted. I can see that the left side equals the right side now. And so I'm finished. I did exactly what I needed to do. I verified the identity. Example 4, we're simplifying an expression, and you look at this and it looks really complicated, but what you have to do is train yourself to look at the formulas. Okay, find the one that this looks like. And it doesn't take very long to see that it looks like this one. Cosine 2a equals cosine squared a minus sine squared a. Notice the pattern, notice what it looks like. Okay? So a in this case must be 7x. Okay? A must be 7x in order for this to work. And so if A is 7x, that's going to be cosine 2 times 7x. Now these are called double angle identities for a reason. It just doubles the angle. This is cosine 14x. That's it. Okay? Some of these don't have to be difficult. Some of these are supposed to be fairly straightforward. So then when I look at part B, sine 15, cosine 15, okay? Look at the identity that it looks like. It kind of looks like the sine double angle to me a little bit, but it also looks like one of the product to sum that we haven't talked about yet, I guess. But to me, it most looks like this one. Sine A cosine B equals 1/2 times the quantity sine A plus B plus sine A minus B. To me, it looks like that one, where we're looking at the left side, and A is 15, and B is also 15. And so if you were going to let A and B both be 15, I'm writing down a lot more than I think is necessary, but look at what we would have if A and B are both 15. I look at the right side of that identity, and it says 1/2 times the quantity sine 30 degrees plus sine 0 degrees. But we know sine 30. Sine 30 degrees is out of the chart. That's 1/2. And sine 0 degrees is 0. And so, you look at 1/2 times 1/2. 1/2 times 1/2 is 1/4. So again, the key is find the identity that looks like it. Okay, let's do example 5. write sine 3x in terms of sine x. This was a little bit harder, I think, because it doesn't look like any of the ones on the board. We don't have any triple angle identities. Best we have is a double angle identity, and so that's kind of the key. I want to break this down into something workable. I believe you had a problem like this on your homework, but not very many of you asked me a question on it. What I want to do is take this 3x, and instead of 3x, I want to think of it as 2x plus x. So obviously that's true. 2x plus x is 3x. But what I've done is I've changed this into a sine sum. And so sine sum from 7.3, we could use the sine sum identity, and that's the one that says sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. So I've used a sine sum to basically get rid of that 3. I don't have a 3 anymore, but I still have a couple of double angle identities, and I can use those double angle identities. Now, I guess we haven't done a good job of reading the directions yet, right? Sine 3x in terms of sine x. Basically, what they're asking me to do is write this whole expression only using sine. Okay, now we might have a sine squared or 5 sine cubed or something like that, but we're only going to have sine x. We're not going to have any cosine x or anything like that. And so I don't want any double angles either, I guess. Let's start with this sine 2x. Sine 2x is a double angle identity, and I know I can change that into 2 sine x cosine x. Let's just bring that cosine x down for now. And then over here, I see cosine 2x. I don't want cosine, I want sine, okay? I don't want 2x either. I don't want cosine 2x, I want something in terms of sine x. And so remember with the cosine double angle, you've got 3 options for the double angle cosine. Well, there's only one that makes sense to me. I'm going to pick the one option that only has sine in it. Okay, don't pick one of them that has a cosine in it. Pick the one that only has sine in it. So I'm going to change this, and I'm going to say that is 1 minus 2 sine squared x. And then let's just bring down the sine x. So it looks pretty complicated, I guess, and it looks better though because I don't have a double angle anymore. I do still have some cosine x in there, so let's clean up a little bit. I've got 2 sine x cosine squared x, and then I'm going to distribute over here, plus sine x minus 2 sine cubed x. Sine squared x times sine x is sine cubed x. Okay? And sine cubed x is fine. I just don't want sine 3x. That's not. All right. So I'm pretty much in terms of sine. The only thing that I'm really not good on is right here. I don't want that cosine squared. Okay. So go back and think about something that we've done before. Remember how sine squared plus cosine squared equals 1? Sine squared plus cosine squared equals 1. I know I abbreviated that just to save room, but cosine squared is 1 minus sine squared. You ought to be able to do that in your head, but I know cosine squared can be written as 1 minus sine squared, and so that's what I want to do. Right there. Everything else can just stay the same. I've got 2 sine x plus, times that 1 minus sine squared x, plus sine x minus 2 sine cubed x. And I'm pretty much finished. I'm only in terms of sine x. The only thing left to do is simplify. Okay, I can distribute. I'm going to have some like terms. Let's go ahead and do that. Distribute this to sine x. I would have 2 sine x minus 2 sine cubed x. Bring down the rest of this, plus sine x minus 2 sine cubed x. And then you notice, or you should notice, hopefully you've got some like terms there. That's going to be 3 sine x. And then here are some sine cubes that can combine. Minus 4 sine cubed x. That's it. We just wrote our identity in terms of sine x. And that's all there is to it.
Example 7, we're trying to write this expression as the sum or difference of two functions. And so what you should notice is that it's going from a product to a sum. And so we're going to do some of the product sum identities. And so you look at your product to sum identities and try to find the one that looks like this. I realize none of them have that 4 on the front, so that 4 is just going to kind of hang out in front of your expression there. Cosine 75 times sine 75. So you got cosine times sine. Cosine times sine. So you look at one that says cosine A sine B equals 1/2 times the quantity sine A plus B minus sine A minus B. So we would be looking for that expression, and hopefully it's obvious that A is 75 and B is 25. And so I don't know that you need to write all this down, but if you know that A is 75 and B is 25, then you would recognize that you're just going to add those two numbers together and get 100. You're going to subtract those two numbers and get 50. And so what we're going to have is, of course, we have that 4 in the front, but then when we substitute in that expression, the other side of that identity is going to be 1/2 times the quantity sine of 100, because that's 75 plus 25, or A plus B, minus sine 50 degrees, because that's A minus B, or 75 minus 25. And so we can clean this up a little bit. 4 times 1/2 is 2. And I'm going to distribute. Generally, we don't want to leave the parentheses in there. We distribute the 2. We're going to have 2 sine 100 degrees minus 2 sine 50 degrees. That's it. We try to write that expression as a difference of two functions. This is in more identities. And example 8, we're doing sine 2 theta minus sine 4 theta. We're trying to write it as a product. And so you notice it's going from minus to a product. And so you should look for the sum to product identities. So find one that says sine minus sine. You see the one that says sine minus sine? Sine A minus sine B equals 2 cosine A plus B over 2 times sine A minus B over 2. It's all about pattern recognition. Can you find the right pattern or identity? And so when you're looking at this, again, I don't think you needed to write that down. You can do a lot of this in your head, but notice that A is 2 theta and B is 4 theta if we're looking at this pattern. And so A is 2 theta and B is 4 theta. On one hand, we're going to add those two things together and get 6 theta over 2. And over here, on the other hand, we're going to subtract those things. 2 theta minus 4 theta is negative 2 theta over 2. We can clean that up a bit. We have 2 cosine 3 theta times sine of negative theta. Now it's a little bit weird. It's a little bit weird to have that negative in there, that negative angle. And so remember one of the negative angle identities, or the fact that sine is odd. Remember what that allows me to do with that negative. It allows me to pull that negative out. Okay. And so since sine negative theta is equal to negative sine theta, what I'm allowed to do is take this negative and just pull it away. And so what I would say is negative 2 cosine 3 theta times sine theta. And what we've done is we've just written a difference as a product. So we would sum the product.